Sorry about sorry about this one, fellas, but it seems sorry, boys, but the good stuff doesn't appear until you get to the minute 13 mark. So go to 1 minute 13, and then the explanation will start. My bad. Okay, so we've spoken previously how we can approximate a binomial distribution with the normal distribution, and as long as our normal distribution is big enough, um, it does a pretty good job of it. So the same applies for our sample proportion. Okay, so if we're going to sample a larger population, as long as the sample size is suitably big enough, um, well then our sample will be approximately normally distributed with a mean of p and the standard deviation of square root of p times 1 minus p on n. Okay, so look, it really is a fairly straightforward application of that. So we're saying that on average, 50% of children born at a hospital are female. Okay, fair enough. Find the approximate probability that more than 60% of the next 25 children born at that hospital will be female. So there's my sample here. All right. So there's the sample that I'm going to take. Okay, there's my probability of a female being born. So the population distribution P is equal to a half. My sample size is 25. So because it's suitably large enough, approximate probability, we can use a normal approximation. So we know mu is equal to P, which is just equal to a half. And I also know that the standard deviation sigma is the square root of a half times 1 minus a half over 25, which is equal to the square root of a quarter on 25, which equals, well, square root of 1 on 100, which is 1/10 or 0.1. Okay, so that means now all of a sudden my sample is distributed normally with a mean of 0.5 and a standard deviation of 0.1. So probability at 60% of the next 25 children born, more than 60%. So I need the probability that p hat is greater than 0.6, which is equal to normal CDF. Okay, remember we'll go 0.6 to 1 because you can't get a bigger proportion than 1. And we've got a mean of 0.5 and a standard deviation of 1. And that'll give me 0.1587, which we could have kind of expected because if you have a look at our 0.1 and our 0.5 there, it's sort of one standard deviation above, isn't it? So if that's 0.5, that's 0.6. So the chance of being in this section here, well, that's my 16%, isn't it? Oop. That's sort of 16% at that end, which is that sort of 0.1587 mark. Okay, so it seems like a reasonable sort of answer. Righto, off you go.